Greetings, fellow rocket scientists, and welcome to my new series where we'll be exploring the physical sciences and the mechanical marvels that make up Kerbal Space Program. And in this series, we'll be finding out how gravity, atmosphere, lithospheres, and anything else we can think of affects our rockets and space planes. We'll also be delving into the building of the game where we're trying to design the craziest builds of rockets, space planes, and even the most efficient and anything else we can probably think of. In other words, I'm just going to mess around. So let's go and have some fun and try and learn something as well, because that's the idea of this series. Anyway, let's start off with terminal velocity, and I want to find out what the terminal velocity of a 3-manned command pod is in Kerbin's atmosphere. So to do that, let's take a look at our rocket, which we're going to do our testing. And you can find this information, by the way, on Kerbin Space Program's wiki page on Kerbin, the planet. It'll give you the altitudes and the terminal velocity. They say that the reason why it's useful is because they tell you to keep at least don't go over terminal velocity while you're launching up into space, if I can get that out. Yes, and that is what I'm going to do. I'm going to find it out, and then we can compare my results to those that are in the wiki. Anyhow, let's get this show on the road. And how I'm going to test this, you might be wondering. I'm going to launch this rocket up to different altitudes, let it fall back, let it decouple then the capsule, let it fall back down, and record the altitude at which the speed stops accelerating. And that then will be the terminal velocity at that altitude. So if you don't understand that, don't worry, because I'm going to show you how to do this experiment. So let's start the first run. I think for the first one we'll just get out to the atmosphere, then fall back down. So map at the ready. In 3, 2, 1, launch! And the first stage of our science is on the way. Now, what is terminal velocity? Well, it is the effect of gravity versus the drag that is caused by the atmosphere. And in other words, when you're coming down, when gravity is pulling you down through the atmosphere, it is pulling you at an accelerated rate. And what happens is when you are falling, stop us here, and now we have to just keep it over the atmosphere. And what happens is the pressure of the air coming under it also exerts a force, which at one point both forces will be equal, and then that is your terminal velocity. You cannot accelerate any further because you get the same pressure as you do the acceleration from the gravity. So you're just traveling at a static speed, if that makes sense to you. There are other videos and helpful Google pages that'll help you understand that much better. So let's get ourselves up to altitude, into space, and then we'll decouple and let ourselves come back down. Okay, I think we're safe enough to decouple now. We will time accelerate until we get into the atmosphere. Here we are. And now, Ledwell, Songi, and Tom Ray Curran. I didn't choose them specifically, they were just dumped in for science. Just in case Jeb, Bill, and Bob don't survive. We get the interns to do the science, to do the dirty work, and then Jeb, Bill, and Bob takes all the credit. So, okay, let's bring him down. Now, I'm watching the orbit speed. I'm going to slowing down, see that? And as soon as it stops accelerating, let's see if it, yeah, it stops accelerating about 900 meters per second. at that altitude. Let me write that down. I might plot this in the graph, I may not. 900 meters per second at 22 kilometers. Okay. Now is no point in resuming this flight and letting this crash to the ground. But we will do so anyway. The next attempts, I will skip this bit and just revert the flight. Explosions. Bugger that. Let's revert the flight and start again. Okay, so we got up into space we recorded at altitude to 22 kilometers. We were at 900 meters per second when our velocity stopped accelerating. And I bet you're wondering why. Let's plan our next altitude. Shall we say 50 kilometers? Or should we go higher? Yeah, we'll go at 50 kilometers. Okay, so full thrust and launch. Okay, so why is the speed slowing down after we reach terminal velocity? Because if terminal velocity is the speed at which your static speed your speed is static, shouldn't it stay at the same speed all the way down? Well, no. Here's the thing. The atmosphere, if I can get, the atmosphere here gets thicker as you get further down. Therefore, it stands to the reason that your velocity will reduce. The pressure of the air is increasing. And that brings me to another point. Because the increase of the air pressure, get the words out. Because the increase of air pressure is increased at a logarithmic scale of some kind or other, it means that we cannot use the speed of going all the way down. We have to keep it at oh, come on, think of it. Try to fly a rocket and do this at the same time. Alright, we've got our altitude there. I can leave that, and as that's climbing up, I can explain. Right, because of the increase of atmosphere as we're going down, it slows our rocket speed down so much that we're traveling slightly faster than the terminal velocity as we're coming down. Therefore, we cannot use that as an accurate speed for our terminal velocity. At least that's my theory, and this experiment may prove it wrong. It won't be the first time I prove it wrong, but here we go. Anyway. Okay, 50k. Decouple. And the reason I'm decoupling the rocket from the command pod is because each part has its own coefficient drag number. And that will cause us to have some slight discrepancies. So I thought if we had the command pod with a parachute, and that's it, because I believe the drag of both of them is 0.2 with the parachute not deployed. Okay, so our speed is increasing. Ready on escape key to pause the game. Yeah, I should always make sure the nav ball is in surface mode. That way it'll be fair. Okay, we're slowing down in speed. And we hit 706 meters per second at 19, well, let's say 19.9 kilometers. Okay, that's 2 altitudes down. We've got 22 kilometers, 19 kilometers. Let's revert the flight and go for the next altitude. Righty-ho. Okay, let's go for our next altitude, which would be about... let's try 20 kilometers. So launching, 3, 2, 1, go! Okay, you can work out your terminal velocity in real life and in Kerbal Space Program. I believe there's a formula for it on the Kerbin, on the Kerbal Space Program wiki. There's also a load of formulas on WikiHow for how to calculate in real life. And in real life, you times your mass and your gravity times by 2, then divide that all by the density of the object which is falling, times that by the area projected and the drag coefficient, and then take the square root of all of that. That gives you terminal velocity. The problem being is that Kerbal Space Program does not use the same physics. For example, the surface area is not calculated in Kerbal Space Program, so you can't use that, but it does have drag coefficient. So I think they use a slightly different formula for that. Trying to keep my altitude about 20 kilometers. If I kill my velocity here, decouple, and bring ourselves down. Okay, so ooh, excuse me about flying back there. Okay, now we're accelerating and we slowing down. 337 meters per second at 12 kilometers. Let's say 12.5. Okay, so we've got 22 kilometers, 19 kilometers, 12 kilometers. Right now, let's try for 10 kilometers. Okay, so let's get the SAS, not time warp. Silly me. Okay, and 3, 2, 1, launch. We'll try, yeah, let's try 15 kilometers altitude. And see what that gets us. From this point on, I may fast forward the video to reduce the amount of time it is to record this video. to reduce the length of this video. Okay, here we are at 15 kilometers. Let's decouple the command pod and bring ourselves down. Now I have to note I don't have Ferrum Aerospace installed, so this is unmodded KSP, well, except for a few little things, but non-game changing mods, I call them. Okay, so make sure that's stopped. Yeah, no. Yeah, so it's 244 meters per second at 8, let's say 8.7 kilometers. Alright then, let's do the last test, which will be about 10 kilometers up. Yeah. SAS engaged, full throttle, met mode engaged. Launching in 3, 2, 1, launch. We have liftoff for the 5th number in our science of terminal velocity. And we will start our altitude separation at 10 kilometers. We need to keep this definitely at 10 kilometers, otherwise this will reduce our science. Come on, let's do some altitude management. Yeah. Altitude management. New words. Words for science. Okay, let's go to map. Decouple. SAS off. And we're coming down. Accelerating towards the ground at a hefty speed. And what should we get? I don't know. What number shall it be? Yeah, sorry. I'm just going a bit too lally. All this science is going to my head. Okay, we're slowing down. Yep, we're at 189 meters per second at 6.5 kilometers. Some slight discrepancies in my numbers, possibly. I'm not too sure. At 8.7 kilometers, we were traveling at 242 meters per second. And at 8.5 kilometers, we were traveling at 189 meters per second. Now, there's not too much discrepancy between the numbers, but let's have a look at the wiki page. See what our numbers bring up. And then we can compare our results and tell them that they're wrong. Okay, here we are on the KSP wiki page, and here we are, atmosphere. Here is how to calculate the pressure of your atmosphere. I'm sure there was something in here about calculating terminal velocity. But anyhow, what we're interested in is our values. Hopefully I might be able to edit them in by here. I can't see them right now, but here we are. Okay, at 22 kilometers. So in between 32 kilometers and 20 kilometers, we were at 900 meters per second. And it's in between there. It's possible that could be correct. Okay, at 19.9 kilometers, say 10 kilometers, almost close to 20 kilometers, we were at 706 meters per second. That is pretty damn close if I do say so myself. And at 12.5 kilometers, we were at 337 meters per second. That is pretty damn close. Excellent results so far, but we're not finished yet. 8.7 kilometers, close to 9, 242 meters per second. My God, we are close. And at 8.5 kilometers, between there, we're at 189 meters per second. Now that does seem slightly out. It might be because the game's been updated all the time. The parts have been updated. Drag perhaps was changed on the capsule, or they used something else to do these values with. Some other capsule or some other parts. Anyhow, that is pretty good results. Let's go back to the game. Resume the flight. Watch these explosions happen. In full force. And we'll return our Kerbals safely. Explosions galore, and I will see you in the next episode where we'll be building something. Ooh, it's quite bouncy. I never knew this rockets were bouncy. And total destruction. Yes, please like this video if you liked it, share it and whatever else, and please let me know in the comments if you enjoyed this. Also, be critical of my commentary because I just need to try and improve myself. Give me encouragement or just tell me, you're doing this wrong. Don't make yourself sound silly. Or make yourself sound a bit more silly. I like it. Or whatever, I don't know. I'm just trying to improve myself and just messing around. Having a bit of fun. Anyway, yes, in the next episode I'll be building something. So, perhaps a crazy rocket. I don't know, I was thinking of something like having the command pod without a parachute surviving a crash by having a load of struts around it or something. So yeah, a crash prevention mechanism of some kind. all in stock parts, by the way. Yes, I will see you in the next episode. Bye bye for now, and keep on doing science.